Hi, my name is Mako Miyatake. I'm a graduate student at the University of Tokyo. In this video, I'm going to talk about our research paper named Flower Jelly Printer. Flower jelly is an artistic dessert in which a flower-shaped jelly floats inside another clear jelly. In the conventional manual procedure, chefs needed to inject the knife. In the typical cooking process, they commonly suffer from three issues: precise and accurate control of the hand, prolonged concentration and effort, impossibility to undo or redo mistaken cuts and fails. Introducing digital fabrication tools into traditional manual cooking processes enables precise fabrication, less human labor, trial and error design installation. In this work, we present Flower Jelly Printer, a novel printing platform that simplifies the challenging fabrication and enriches the design space of the dessert. Although digital fabrication tools have been already introduced into many food fabrication processes, they cannot be applied to all types of food production. Additive manufacturing is not suitable for the slowly cooling and deformable materials like gelatin. Subtractive fabrications are not appropriate for the soft or fragile materials. Using granular gel support, we sometimes see in some other projects, it is impossible to eat the finished structure as a firm jelly. Instead, we developed a novel fabrication method called Slit injection printing. Flower Jelly Printer is a printing platform that allows users to design flower jelly and fabricate them precisely through digital design and fabrication. First, users design their flower jelly with a computational design software. After selecting the favorite flower from the predefined library, users can customize the shape of each petal and the overall structure of the flower. Second, users fabricate custom tool attachments for the printer. These petal knives generated by our design software are 3D printable. Then, they prepare two jelly materials, base jelly and colored jelly. Finally, our 3D printer prints the designed flower jelly by slit injection printing. First, the petal knife makes a slit inside the base jelly, then the printer retracts the knife while injecting colored jelly. To implement this technique, we modified a 3D printer by adding a motorized turntable and a DIY paste extruder. This printer is compatible with the G-code 2-pass compiled by our design software. We conducted a user study for both novice and experienced users to examine the effect of a system. The results showed that novices could easily make flower jellies and professionals could test different patterns until they were satisfied with their design. However, with the convenience of digital fabrication, many users reported a decrease in the pleasure of crafting process and resulting artifact. Another experienced user also found that automation of the fabrication process reduced a sense of connection with the finished artifact. Making the automated process more enjoyable and special for makers is a challenge we aim to address in our future work. In addition to making one-off flower jellies, our proposed technique can be applied in a small batch production process. Reliably producing the same beautiful desserts without hiring an expert chef is one of the biggest goals for professionals. Although we focused on the fabrication of flower jellies in this paper, slit injection printing can be applied to other soft-textured food. We categorize the design space based on its material, property, and application in our paper. We hope that more people will be able to enjoy creating and consuming flower jellies, and this work will open up new possibilities for soft-textured food. Lastly, I would like to thank my co-authors and collaborators. Thank you.